Hello everybody and welcome to the first lesson of web application programming. We will be talking today about layers of the web. Now, whenever you're developing for something, or if you're developing for Android, if you're developing for Windows, if you're developing for any system, you need to understand how that system works. Now, since you're developing for the web, you need to understand how that works as well. So the first step to understanding that is to realize that there is a huge difference between the web, www, the World Wide Web, and the internet. It might not seem that way, but the web is a service that exists on the internet alongside other services like email, online games, voice over IP, among other things. So, in general, web is just one small part of the whole that is the internet. But what is the internet? Well, simply put, it's just a group of computers that are connected to a single network, a single big network. So when you connect your computer to the internet, you're part of it, which means that the information on your computer can be, in a way, shared with other people, if you choose to. Now, whenever a computer connects to the internet, whenever a machine decides to be part of the internet, it gets an IP address. Well, what is an IP address? Simply put, it's an identifier, a way to distinguish machines on the internet. So basically, if you live in a giant city and I need to send you mail, I put your address on the back of the envelope, and that's how you get your mail. That's how somebody who works at the post office, who doesn't know anything about you, doesn't know where you live, doesn't know who you are, can take that envelope and deliver it to your doorstep. And that is because of your unique address. Now, it's the same on the internet as well. On the internet, you have an IP address. Again, a number which represents the actual address or location or directions to where to get to your computer through the web that is the internet. So in the beginning, there was only IP version 4. So IP version 4 does the job, but the problem is it's limited. IP version 4 uses a 32-bit encryption, which means that there is so many IP addresses that can be generated, and as you've noticed, we have outgrown IP version 4, and pretty much all of the possible permutations of IP4 addresses have been taken. So we've just been recycling them. And hence came the need for a different standard, which is IP version 6. So now everything is trying to move forward to IP version 6, which uses 128-bit encryption, which allows for far greater flexibility on addresses. So we will be getting a lot more web addresses. So a lot more machines can join on the web, and a lot more data can be shared between those machines. Now, if you look at an IP address, okay, you'll see that this, for example here, this is the IP address of the machine that is hosting Google. At the top there, you see the IP4 address. At the bottom there, you see the IP6 address, and they're both for the same machine. But you might have noticed that when you try to access Google, you don't type in 216.58.2. You type in www.google.com, and then, bam, you get Google. It's not black magic by any means. This is something called a DNS server at work. Pretty much every IP address here symbolizes a location of a machine. But no one will be able to always remember every single important IP address that they need to. Like if you need to log on to the university website, you're not going to remember just the number of it, or Google's number, or Outlook's number, or any other service's number. So it's easier for you to remember a name, as in Google, as in Yahoo, as in Outlook. And there comes your DNS. Your DNS is basically a giant database stored somewhere. You connect to that database. You ask that database, hey, listen, I'm trying to access Google. Then your database searches that value, finds Google, it finds the corresponding IP address that goes with it, and sends you back that IP address. And now you have the actual IP address of Google. Now all of this is happening in the background. All you get is the results. This is simplifying your experience and making sure that you get a seamless experience surfing the internet, while in the background all of the small little gears are running. So you get the IP address, and you use that IP address to communicate with the machine that is hosting Google. You send it a request, the machine takes that request and sends you back a response. And this is pretty much the basics of it. Now, nothing says that a machine can handle one form of service. It doesn't just have to be a web service, which means that it doesn't just have to be you communicating with a machine to get a web page or the like. You could be getting a web page. You could also be running an email service out of the same machine, but how would that possibly work? The answer here is something called the Transmission Control Protocol, or TCP, or its alternative, the UDP. These are protocols that are built on top of IP, which means you have the base, and then on top of the base you have extra functionality provided by those protocols. The idea here is that you use your URL to communicate with the server. Part of that URL would be your port. If you look at this URL right here, you'll see that there is a port in yellow and it says 80. 80 by default means that you're trying to communicate with something that's hosting a web page. It means you're trying to go on a web page. If you make this request, the TCP or UDP protocols that you're using will decide, okay, they're trying to access a website on that IP, on that server, so this is what they should be expecting and this is what they should be getting. If you're trying to access some other service, that port number changes. Generally, there are preset ports for services. Each service normally is represented by an application, which means for you to be able to access a web page, you need to get it from a web server. A web server is simply a machine that has an application on it, a program, which is called a web server program. You guessed it. So you talk to that program, and that program decides, okay, I am sending that information out, and I'm using port 80. If you have multiple programs that are doing different things, that means you have a program that does web. You have a website, right? And that website is on your computer. You're serving that website through a program, a web hosting program. So that will use port 80. On the same machine, you're using a mail service, a program that hosts a mail service, and that uses its own port. You have a game server running somewhere on the same machine, so that game server uses a different port. So you can see there's one machine with one IP address, but multiple different ports, each corresponding to a different application on that machine. Now, it is part of your URL, whether you see it or not, but then again, your URL has some other components to it. You can see you get the protocol that you're working with, which is HTTP here, for example, which communicates with web pages. You get your actual domain name, which gets translated to the IP address of the machine you're trying to connect to. You get the port, which means exactly where on that machine, which application you're trying to access. From there, you know which machine it is, you know which app you're trying to access. Now you go and you use a directory type syntax in order to get to the actual folder that is hosting your file, and from there you actually access that file. Now on that file you can either have parameters, you can possibly do a request to the server to perform some sort of operation, which is highlighted here as parameters. That means that if you're trying to access that file probably needs you to give it information. Here the information is simply labeled key 1 and key 2. Key 1 equals means that whatever value it is you enter after the equals is the information that you're giving the server. Key 2, the same. And then the AND symbol means that there are multiple parameters. So if you have a request that ends with a file name and then question mark, what comes after question mark are parameters. Parameters are usually separated by AND. Parameters consist of a name equals a value. You can use those parameters manually. You can type them into your URL and make the send request, or usually they are prepared for you by your browser when you fill some sort of form. Also, this pertains to a certain type of request, but we'll talk about that in a little bit. You can also have something called an anchor tag in your URL, which means that, okay, in my file.html I need to be on a specific part. You know, on a web page, how you can scroll down and you can get to different sections. Well, you can actually embed that in your URL. So I can click on a URL, I can go to the myfile.html page, it loads up, I can see it, and then because you have the anchor tag, hashtag somewhere in the document, it automatically scrolls down and it focuses on that part of the document. Pretty straightforward, pretty simple. Now, that URL you use through a web browser. The web browser is a program that is located and that runs on the client. In this case, this would be your computer or your phone. Any device that has a web server on it is considered a client. So you input that URL on your client and you send the request. You just press enter, press go, press whatever it is. Then automatically that machine will connect to the DNS server. The DNS server will translate the domain name into an IP address. It will send the IP address back to the machine. The machine then will take that IP address and communicate directly with that machine to let, hey, listen, get me the information on this port using these parameters. The machine then takes that request, passes it through to the corresponding application according to the port number, and then the application takes your parameter and does its magic, whips up a web page, and sends it back to you. Now you're able to view it on the browser. Now, as we mentioned before, there are multiple protocols to govern the way these different applications receive data according to the port number. And there are mainly two types of protocols that do this, or two protocols that do this. The TCP, the Transmission Control Protocol, and the UDP. Mainly we'll be focusing on TCP. So generally TCP is a lot slower than UDP, but that comes at a good price of being secure, which means that if you make a request, it is definitely going to go through. The protocol will make sure that it does, because it checks if it goes through or not. So if you make a request to a server, the server has to confirm to your client that that request has been received, and only then you can get the response and confirm it and yada yada. For the UDP, it doesn't really care. It just sends a request, the request goes. If the server receives it, if it gets dropped somehow, if your internet is bad, if the internet and the machine hosting the server is bad, and you lose that request for some reason, it's gone. There's nothing you can do about it. There's something to be said about this. TCP is a stateful protocol, which means that it keeps track of what it's doing. It also supports multiplexing, but they both do. Multiplexing just means it can handle multiple applications at the same time. Now, talking about web servers, which would definitely be a good point to start talking about the applications that run on that server. Web servers are just applications that are located on the computer that is hosting the service. These applications, all their job is to receive your request, to interpret it, and send you back a web page. Of course, there are multiple types of servers. As you can see here, you have FTP, email servers, post office server, whatever. You have a lot of possible servers. Each server can run on its own port, and then the TCP protocol will filter out the kind of service that needs to be called, the kind of server that you need to be calling through the port number, and then uses that port number to get your request started. So again, your computer makes a request through the browser. The request goes to the web server. Eventually, after go through the DNS to interpret it, it goes to the web server, and it decides on which application on that web server to call according to the port number. Then the web server sends back a response to your browser so that your browser can interpret it and display it. That's pretty easy. The computer says, hey, just give me cat's not cool, right? So the web server says, here you go, sure thing. And you receive the image and it loads on your computer. The reason that this server in particular knew that you're looking for a web page is that because it received this request on its port 80, which is reserved for the web server application that is running on that machine. So then when that request was received, the machine interpreted it as a web call, and then processed it as a web call, and it sent you back the response as a web page. There are multiple types of requests. Mainly there are idempotent and non-idempotent requests. Idempotent means that it's changing the data or not changing the data. We'll talk about that in depth as we go through with the course, but the idea is you can have GET requests, which simply talk to the server and say, hey, give me this web page, and you get the web page. There are POST requests, which means you have data and you are sending it to the machine, the server, and you're saying, hey server, please take this data and store it, or do whatever you want with it. There are PUT requests, again, to store data on the server, and we'll talk about those in depth when we get to server-side program. I have delete requests that simply erase data from the machine. GET requests are idempotent because you do a GET, you get the data, nothing changes on the server. POST requests are not, because every time you do a POST request, the data on the server can change. PUT requests are idempotent because you do send data to the server, but you're adding, you're not really changing. So we'll also be delving deeper into them as we go on. Now, your best friend on your web browser is your developer tools section. Basically, if you right-click any web page and you select developer tools, you will get a screen where you can actually see what's going on in the background. You can see, if you go to the network tab of those developer tools and you make some sort of request, you will watch and be able to see that request go to the server, and at the bottom there you'll be able to see a response. The response tells you exactly what happened, if you're getting a response or not, you're getting a web response or not, and then it gives you a body. The body actually represents the web page, so we're not going to care about the body too much for now, but I want you to take a closer look at where it says status code 200. Okay. So basically, when you do make a request, which is the upper part of this page, when you do make a request, it goes to the server. If all goes well, you get a 200 status code. Well, that means that you have multiple status codes when making a request. If the request happens successfully and nothing goes wrong, you get a 200 status code. If the request ends up changing the URL and directing you to a different page somewhere else, then it's a 300 status code. If you make a request, but your request has an error in it, the most famous one would be 404 page not found, which means that you're talking to the server and you're saying, hey server, I need this. However, what you're talking about does not exist on that server. The server sends you back a response that says, hey, listen, 400 status code, this does not exist, I don't have access to it. You're trying to get into something that does not exist. And finally, 500 status codes. You're talking to a machine, that machine has an application on it. If something goes wrong with that application, it's going to send you a 500 error code. Usually, if something doesn't work properly inside, if some code isn't written the way it should be written, that's what's going to happen. You're going to get an internal server error, which means that it's not on your end, it's on the server's end. There's nothing wrong with your machine, with your client. There's nothing wrong with your URL, your request. It's just that that machine had a problem with it, had a problem with its web server that prevented it from actually giving you the response that you were looking for. Finally, there is a lot that goes on to web application. Basically, you have different layers of what a web application is. we will be focusing on two main areas here. We'll be focusing on the front end of the web application and the back end of the web application, or the web page in this particular instance. The front end is what faces you, is what you see when you go into a website. It's the page. What buttons you interact with, what text you can see, what pictures you're able to view. The way we will be implementing this is using HTML, CSS, and JavaScript. Pretty much HTML is the foundation of your page, while CSS is the looks and the beauty of that page, and JavaScript is all of the little knobs and buttons that make that web page actually interactive and work. There are other ways of doing front end, including Angular or React or other types of front end development. Now, through Ajax and JSON, which are gateway tools of transferring data from the front end, you can take data that the user inputs and you can move it to the back end. In our course, we will be using Node.js as the back end, which means that we can take that data, we can do something with it, and then we can send back the response to the web page, the front end, so that the user can see it and can have an actual information what they did. That will be about it for now, but stay tuned because more and better is coming.